Hi there, welcome back to another instalment of Austin's Oddities. I'm just going to redo a video I've done previously. I didn't do it very well, I've only just started doing this, so bear with me. The quality of content isn't necessarily synonymous with the quality of production, so just bear that in mind when you have a look at this. But if you pay attention, pause it if you need to absorb the information. I think you'll see it all does link up. And I know it's a bold claim, but the evidence is all there. I can prove it 100%. So without further ado, let's get into it. Now, if you notice in nature, you've got like all these different, well, they're different, but they're all the same reactions that create the Giant's Causeway. You get the hexagon at the top of Jupiter. You've got a hexagon on the eyes of a fly. I'll put all these pictures up, by the way, have a look at them. There's a hexagon, and when we look in the lens of a camera, we see like a glare from it that splits itself off into these six forms, these six jets, and we can see it in a barrel of a gun, and that's what really clicked it for me. There was two things: the snowflake and the reaction for the barrel of a gun. Now I'll put a picture up for that as well, but if you notice that as the gun goes off, there's six jets of fire and then six spaces without. Now when all that energy is released in that compressed space, you think literally nothing would be able to stay apart. You think everything would be mixed up, wouldn't you? But it just goes to show that the repulsion force experienced between the two when released, and I'll explain what I mean by the two in a second. You can see that they're separating. There's no way that anything else would be able to have this reaction. It's such a strong reaction, and that's a repulse force between what I'm going to call fermion and boson. Now, it's not what science calls fermion and boson. Science thinks boson something else, but I'm going to say fermion and boson in the terms of positive and negative. Okay, that's what everything is: frequencies, positive, negative. That's all exists, and then in between. That's why we have the three all around, and I'll come to the three in a second, or the 3, 6, and 9. But that's where I saw the reaction first, and then I sort of investigated into it. It's quite easy to do, and it's I think the difference between an intelligent person and a person of questionable intelligence is the way they think about things. It's not knowledge. I mean, we're led to believe that knowledge is intelligence. Somebody like can recite things, oh, he's so intelligent. He's not. He's got a memory. That's not intelligence, is it? A computer's got memory. It's got some intelligence, but it's not got cognitive reasoning skills or anything, is it? So anyway, back to the thing. So it's the way you think about things. I think about things by educating myself on the fundamental principles of them, and then working my way out from there. So I only know as much information as I need to know to make an educated decision to look into the next place. And that's the way you should think. But if you're a scientist and you've spent years and years and years researching all these different things, all these different words, all these different pathways going off in your head, and you could get lost. Somebody could say that, and then there could be a rule or something, a law that says you can't do this, and then you steer away from it. But then that could be the answer, And it's a shame, really, because it's overthinking. But I think when you reduce something down to its fundamental principles, and then you work your way off those principles, it's just the best way to think. And I'm going to show you what I've come up with anyway. So, as always, I'm going to go and refer to my technical department, who whips up this. So here we see. Now we've got positive and negative on this side. Okay. So obviously in between, neutral, positive, negative, neutral. Same thing, you've got acid on the pH scale, and then on its opposite is alkali, and then you've got your pH neutral, so positive, negative, acid, alkali. Then you've got solid, right? So three same forms of matter, states of matter, whatever you want to call it: solid, liquid, and gas. Now, solid has got lots more fermions in it, and our fermions are like what make up electrons, basically, and they all bond a really tight bonding experience. So the more electrons it's got, the more solid it's going to be. So more fermions, are relative to electrons, because the fermions are what create electrons, but I'll get to that in a minute. And so then you've got gas. So the gas is more of a boson state. It hangs out in the boson field, like, you know, and that's what comprises of our atmosphere. You know, that's basically oxygen, boson. And now we see, like, in between, you've got halfway in between fermion and boson, full fermion and full boson, you've got both equally, which is liquid. So it's halfway in between the solid and the gas. Yeah, so you've got your 1, 2, 3, your 4, 5, 6, and your 7, 8, 9, and your 3, 6, and 9. So your fermion is your positive reaction, and your boson is your negative reaction. Now, for some reason, science recalls electrons as being negative. I don't understand that. There's something that of inertia there. You know, they're positive. It doesn't make any sense to me. But anyway, so for this, we're just going to say that fermion equals positive, boson equals negative. Right. Here I've just put the three sort of. So these are three forms of matter, I guess, and these are the three states of matter: subatomic, atomic, and astronomic. And when it comes to each one of those, they've got to be opposing. So in order for three states to exist, they would have to have opposing reactions of positive and negative. But I think I'm jumping ahead of myself from there. So I'm going to go to the beginning. So we're going to say this is how everything was, like frog spawn, and then you've got antimatter in the centre, you've got your positive material, your fermions, and you've got your bosons in there as well, and there's just bucket loads of them, more than bucket loads, there's a hell of a lot of them out there. So then we have the Big Bang, and it changes the denominations of these, and some have just positive, some have just negative, some are completely voided of all their contents whatsoever and shrink down and become neutrinos. And then so that's basically how we set in motion, because when they're different varying combinations and permutations of positive and negative, they're creating these structures, these covalent bonds and all that. So now we go to the current model of the atom. Now this is it looks like a bonded material there, and then you've got these orbiting around, and that bollocks. It's wrong. Excuse my French. So this is what it's really like. This is what's going on. You've got a little bit of antimatter in there. You've got your positive, your negative. Your positive there, you've got your electron, which is basically fermions that are replaced into a shell again due to a resonating force in the presence of matter, and it just shakes the business out of them, and then just rubs them back into the. Oh, I haven't done a thing for that. Oh, damn it! Oh, never mind. I'll just explain it anyway. So these things here, right, they're rubbing around the outside of the shell. Now the reaction between repulsion between matter and antimatter pushes them to the outside of the shell, so they haven't got any direct force. So they're going with it, so it doesn't require much force to hold those in at all. But when they get hit by waves, now waves are just fermions that are set free out and they're not contained by any reaction. So they're whizzing away and they'll bump into this, and if it's in orbit, it will shake it about, and when it shakes it about, you think like a salt shaker, little bits come out, and those little bits, in the presence of matter, say in a boson field in our atmosphere or whatever, when that happens and these waves resonate the atoms that are just hanging around, and they start releasing all these things, which are then in turn rubbed into neutrinos, which are just everywhere. There's about 50,000 of them that go through your thumb at any 1 second. Now these little neutrinos just hanging around waiting to live life again. I'll tell you how they were born in a minute. But these little babies, yeah, so when atoms get shaken around and those little bits come out, they get rubbed into these. Now I suppose there's varying quantities, and it probably has its maximum capacity, because as it hasn't got an antimatter bit inside it to swell its shell out, it's only tiny, so it's probably only going to let a little bit, there's got to be a standard amount, I guess. Right, so now we go to the reaction. So this is the gun barrel flash thing I was talking about. Now, it goes out of mine. Now this is the reaction, this is what's going on. So there reaches a point of singularity, I'll be honest the right way, there reaches a point of singularity where all this energy is released, but then when the fermions or bosons are released out of their shell, they repel each other, as we see in the gun barrel. So that's what creates these 6 jets. You have these 6 jets of fermions and these 6 jets of bosons, because that's how it always divides itself up when energy is released. But then what we have here is, as this reaction is going on, there's all these neutrinos that are going through the system as well. They're passing through. So what happens is this energy release pattern creates a vortex. So these vortices, this one is spinning round that way, yeah, and that gets filled up with relative quantities of fermion and boson, perhaps. I don't know how the quantities would work out, but they would all be varying, so they all look like different particles. So rather than when you open up an atom and you find all these things inside or whatever, it's just the vortices created by the moment. So this moment's going off, you've got your electron up here, and then you've got your what's his face down here, your proton. But protons don't really need to exist within a boson field, because they could just borrow it straight out of the boson field. It's everywhere. So every atom of our body, because we were born inside this atmosphere, is actually bonded to the boson field, which is why we feel inertia when we move our hands, go backwards and forwards, or when we're in a fighter pilot plane or whatever, you feel that G-force. That's because every single one of your atoms are bonded to your environment. That's why stuff don't need protons within a boson field. Like, there's not many of them about, like, well, relatively speaking. So anyway, we get to these vortices, right? So you've got, they call it up, down, top, bottom, these 6 leptons, 6 gluons, and then they say they're looking for a 6th boson, but they think there's 6 bosons. But I think this is the reason why they can't see it. They haven't developed the way of seeing this yet. So this is the last one, which is the opposite to the electron. So these have all got varying quantities of whatever, and this one's got the very least, is probably why they're struggling to find it. But then you've got like up, down, top, bottom, left, right, tau, neutrino, muon, tau, muon, neutrino, tau, neutrino. Then you've got the bosons, whatever, Higgs and blah blah blah. But that's kind of how it goes. But then I kind of come across this pattern, yeah, which is really strange. Now, this is the sort of thing that's developed through vortex mathematics. Okay, so the base fundamental patterns are created by life through an energy experience, like I've just showed you there, is actually portrayed in this thing. Now, in what do they call it? Sort of nuclear physics, or I don't know. Just when they're writing equations for frequencies and stuff like that, they use an X. There's X marks the spot. But you see, if with every part within this pattern, X marks the spot, yeah, is actually collated with the other bit of information that I've got. That's just absolutely mind-blowing. So it's like this stuff's already out there, like imprinted in I don't know, in history and stuff. It's just so deep, I really can't begin to explain it to you right now. But anyway, right. So then we get to the sun, right? So the sun's just pure fermions, which is why they think it's made of hydrogen, even though hydrogen's a highly combustible material, and it don't make sense. So this is all just pure fermions, right? And it's pushed out any neutrinos, so it can't contain the reaction. So it's like a big fusion reaction in the absence of neutrinos to contain them, which is why the centre of our Earth is actually molten, because neutrinos can't penetrate that deep into the Earth. That's why scientists have dug observatories like really deep into the Earth to try and observe them, because there are less quantities of them. So that's what's going on there anyway. So now the sun, yeah, the reason we've got solar flares is, say as the sun spins around a galaxy, it comes into contact with some clouds of matter that have got both fermion and boson, and the attraction factor of it overrides the repulsion factor, and this matter, even though it's got bosons in it, gets pulled in, but then the shells get destroyed, and the bosons then get shot straight back out by the repulsion factor of them, shot right out with a violent force, and that's why we get solar flares. And they will always come from the side. So, we're only at risk at a certain point at any given time. So we go to the slot test. Yeah. Now, if you know science and that, and you've researched it, you see there's a slot test. Now, when the way it goes is they were shooting some electrons through a graphene sheet with a couple of slots in it, right? I do like a couple of slots. I edit that bit out. Where was I? Oh yeah, too busy thinking about the slots. Right, yeah, they're shooting the electrons through this graphene sheet, right? Now, first of all, at low wattage, it does what it should do, it bounces through and blah blah blah. But then when they pump up the wattage and it goes through the graphene sheet, hey presto, we've got 6 lines with electron hits and then 6 lines without, and that's what's created by the reaction that I showed you before. This reaction where it splits off into 6 jets of fermions, 6 species of bosons. They join the boson field. The jets are either rubbed into passing neutrinos to create electrons if they're in the right conditions, or they just go off in waves and become radiation of some degree, depending on their velocity, I guess, and their spin. Right, so now we're going to go to the what do I call it? So this is a galaxy, a side profile. Right, you've got your equilibrium there. You've got your influence of your black hole as a vortices goes round, and there's not really much influence around these parts. These parts are relatively free from neutrinos. So what's happening, right, is that, say, a solar system gets pulled into a black hole, yeah? Now, it shoots off a burst that are witnessed by scientists that have gotten baffled, but it's actually all the luminosity of a galaxy all at once in about 7 seconds. And the reason for that is, oh, excuse me, the reason for that is that with a galaxy you only see the surface luminosity. You don't see every single fermion of every atom of every covalent bond on the whole planet, you know, on the whole galaxy. You just see the surface luminosity. So that's why they're experiencing that. And what that is that as it's getting the scientists witnesses jets of radiation coming out the centre of a black hole, and that's what's going on. There's lots of stuff being squeezed in, but there's an initial flash that goes off as well. Now, fermions and bosons repel each other, which is a good thing, because otherwise this would be some sort of laser cutting through space and killing mashing everything up that come inside. Because if fermions and bosons repel each other, it actually goes outwards, so it dissipates after time. But what's happening down here is we've got what I consider to be dark matter, I guess. And that's the antimatter. So when they get separated under the crushing experience of a black hole, the fermions and bosons get shot out their things to the matter, but the antimatter gets shot out the back. Now that all collects as a cloud, and that becomes like a buffer between galaxies, I think, to stop them, because they're both positively charged, you know, from banging into each other. I don't know, but I guess that's their function. But every single atom of a solar system, an entire solar system that's crushed down, the shells of them are then shrunk down and they become neutrinos. And that's what causes the expansion of galaxies, and that's probably what causes the Hubble constant as well. You know, like, so there it is. I mean, that's the state of things. Yeah, scientists have got it all wrong because they're thinking a bit like too much. You know, fair play to them for dedication to their job and everything, but I've managed to do it, and I was probably working on that one for about 6 months before I cracked it. But yeah, there it is. So you got any given time, energy release, you've got this moment that's always created. So it's got these 6 parts, and then you've got the vortices, which are relative to it, which creates varying degrees of fermion and boson in different quantities into passing neutrinos. Like we've got in here, X marks the spot. I notice a very familiar site. How long has that been around? I wonder. So yeah, so then we've got the 3 states, subatomic, atomic and astronomic, with varying attraction and repulsion factors to give them stability in different states. And then we've got the 3, 6 and 9, blah de blah de blah. So we've got the chemical reaction, we've got the oh yeah, so that's something I didn't put down there actually. So subatomic, if the attraction and repulsion is fermion and boson. Atomic attraction and repulsion is electric and electromagnetic, and astronomically attraction and repulsion is matter and antimatter. So boom, stick that in your pipe and smoke it. You imagine the amount of money it's spent on like, trying to work this stuff out, and all you have to do is just like think about it properly. What waste of money, what mugs we are. You'll have a good one. I'm jumping off.